All right, let's do problem number 11. No, 10. So number 10, you're given the temperature and the pressure. So we're going to do what we normally do, which is start with the saturated table. I think I'll start with the pressure, 2400. So I'm going to the table where pressure is in the first column, saturated water, and I go to about 2400. Oh, there's no 2400, but there's a 2250 and a 2500, right? So I can see that it's around 220 degrees, just kind of guesstimating to be on the saturated table. But here the problem is saying that you're at 100 degrees. So this means you're much cooler, right? You're subcooled. So you're not under the dome, which is what the saturated table describes, but rather you're to the left of the dome. So you are cooler than you should be. So that means we're a compressed liquid. So I'm going to go to the compressed liquid table. And the lowest pressure on the compressed liquid table is 5 megapascals, whereas this problem says you're at 2.4 megapascals. So what do we do? Well, ultimately, we're going to go back to the steam tables and then just use the value very close to saturated liquid as our estimate. If you want to see more about this or read about it, it's contained in this section of the book. This is section 3.5, properties. That's what we're covering right now, saturated liquid, vapors, how to look up all the properties. And you can see here there's a specific compressed liquid state, and it says right here that you should estimate properties, specific volume, internal energy, or H, by just assuming that you're going to use the saturated liquid property, Y of F, at the temperature. Now, it's important that you use it at the temperature rather than the pressure, and I'll show you that in a minute. And then for H, if you want to, you can do this correction, which I talked about in class, which is H is equal to H of F at T plus this pressure difference times specific volume. So that's a correction for this estimate. Remember what we're doing. We're over here in the the compressed liquid phase, but we're just going to use the saturated properties as our estimate. So I know I'm in compressed liquid, so I'm going to go and write that down, compressed liquid. And I know that then the quality is not applicable. So what to do about this H? So as I mentioned, for any of these compressed liquids where you're not on the chart, you can estimate all the properties, specific volume, the internal energy, or the enthalpy, or the entropy, by going to the properties, the saturated fluid properties, saturated liquid properties at the correct temperature. And then you can improve the accuracy for H only by this equation here. So if I go back to the steam tables, and I'm going to go to the temperature portion, not the pressure. That's what this at T means. Here's 100 degrees Celsius. And if I read across, I see that H of F is 419.17. So that would be my estimate, 419.17. That's one estimate. Let me write it down here. That's what we get. Now notice if I had gone and used the H of F at the pressure, so 2400. If I went over here and I interpolated for 2400, I would get something around 950. That's a big difference than 419. So you can see that you really do need to use the temperature as the estimate. And the reason is, what's happening is that you know that H is equal to, it should be equal to a function of temperature and pressure. But what we're doing here when we do this estimate is we're just assuming it to be a function of one of these. And we know that, or I'm telling you, that they're much stronger functions of temperature, that the properties, the thermodynamic properties, are stronger functions of temperature. That's why we're going to use temperature as our single independent variable here. Now let's do this equation where we get more accurate. And notice what this is doing. This is essentially, these are functions of temperature. And now we're including this function of pressure which is more like what our thermodynamic relationships tell us. So if I go back to the steam table, and I go to 100, and I get the saturated liquid value, H of V, at this temperature, and I get the saturated pressure, 84. Wait a minute, where am I? Here I am. 102.42 here. And I use the pressure that was given, 2,400. Then I check the units, meters cubed, kilograms times kilopascals. If I go to the back, I see here that a kilopascal meter cubed is the same thing as a kilojoule. So it makes me feel good. I throw in this unit conversion here. I do the math. I see that if I just use the saturated liquid properties at the temperature, it's 419, this correction adds 2.34. So what is that? That's about 4%, 0.4% correction to give me a little bit more accurate value. So perhaps that's the value I should put down here is 421. All right, that's number 10.